So in previous class, we have already done the numericals based on the LTI system, and as we have seen how we can solve the numericals on LTI system. Now in today's class, we'll be focusing more on in fact only on the discrete time LTI system. Okay? So the discrete time LTI system, if we talk about discrete time LTI system, we can write y of n. Now the output is y of t. We all know that the output is y of t, right? In continuous time LTI system. When we are talking about discrete time LTI system, the output definitely would be y of n, correct? The time output will be y of n. Now the x of t will be replaced by x of t. What was the formula when we were calculating in continuous time LTI system? It was y of t equals to integration minus infinity to infinity x of tau h of t minus tau d tau. That was the formula that we were solving for calculation of y of t for any continuous time LTI system. Okay? Now when we are talking about discrete time LTI system, the output will be y of n. Now we have the another variable, as we know that we need to take the another variable. Another variable मतलब पहले हम continuous time में we used to take as tau as the another variable. Here we will be taking k as another variable. So the formula will be written as y of n equals to summation. Instead of integration, we'll take summation. Summation from for k minus infinity to infinity. The variable here are taken is k. ठीक है? K is minus infinity to infinity. X of k is taken, then h of n minus k. So this is how we'll write the formula for calculation of y of n in discrete time LTI system. Now the rest of the properties that we have studied for continuous time LTI system will be same for discrete time LTI system. The thing is only here it will be in terms of discrete. That's it. Now if I write x of n convolution del n, what would be my answer? X of n convolution del n. क्या होगा आंसर इसका? जल्दी से बताओ. What would be my answer? X of n convolution del n. Yes, students. If I have to take this, in this case, it will be again the summation k minus infinity to infinity x of k del of n minus k. Now n minus k will exist only for n minus k मतलब यहाँ पर ये आपका n minus k रहता है. तो n minus k this will return as k minus infinity to infinity x of k del of n minus k. Now this will exist only at the value. कहाँ पर exist करेगा? Only at n. It will exist. It will have the value only at n. Am I audible to everyone? Am I audible and visible to everyone? Right?
Yes.
Yes, students, reply. Yes. Okay. So this will exist only at the value of n. Here n is not a variable; it is our some value. Okay. So it will exist only for n. Now hence this x of k will exist only at this value n. So we have written x of n convolution del of n will be equals to x of n only. Clear? So that is how we have to write. So x of n convolution del n will be equals to what? It will be equals to xn only. Clear? Now the next, if I write x of n convolution del n minus n naught, what would be the answer? X of n convolution, this one is convolution, del n minus n naught. क्या होगा इसका आंसर? What is the answer of this one? X of, yes, anyone? It will be x of n minus n naught. Clear? It will be x of n minus n naught. ठीक है? So this is how we'll get the answer. This will be x of n minus n naught. Now if I write x of n convolution un x of n convolution un. In that case, what would be the answer? क्या होगा? This will be
x
written
of
as,
n.
हाँ, ये un है. This is un. Don't forget. This is minus infinity to infinity. Here we write as x of k u of n minus k. Now, where does this u of n minus k exist? कहाँ से कहाँ तक exist करता है? जल्दी बताओ. कहाँ से कहाँ तक u of n minus k exist करता है? Yes? Yes, correct. It will exist from minus infinity, not infinity. This will, because it is u of n minus k. N minus k है. This is k is the variable here. Here we have to just focus that k is the variable. It is not n. N is not a variable. It is actually like u of minus k plus n. तो माइनस के मतलब डेफिनेटली फ्रॉम माइनस इंफिनिटी इट विल स्टार्ट, राइट? तो माइनस इंफिनिटी टू k भी नहीं होगा, इट विल बी माइनस इंफिनिटी टू n होगा. n इज अ वैल्यू, k इज अ वेरिएबल. तो k आपका माइनस इंफिनिटी से स्टार्ट होगा एंड इट विल गो टिल n. So this value will exist for minus infinity to k. Is this thing clear now? This will exist for minus infinity to k. तो ये क्या हो जाएगा आपका k minus infinity to n, and this will be just x of k. ठीक है? So this value will be, if we are convoluting this thing x of n convolution u of n, if we are convoluting x of n and u of n, the answer will be summation. It will be minus infinity to n, minus infinity to n with x of k. ठीक है? So that is how we'll write. Now if it is of another form, x of n convolution u of n minus n naught, then what would be the answer? इसके केस में आंसर क्या होगा? Summation k minus infinity to n minus n naught, right? That is k minus infinity to n minus n naught. This will be x of k. Clear now? So that is how we will write. So these are the approved, these are the proved results. ये आपके proved results है. आप directly इसको लिख सकते हो. This is nothing but just by taking the logic of it. That is कि कहाँ से कहाँ तक ये lie करेगा इसका range. That is how we will write. So whatever is our xk, that will have the value only from minus infinity to n minus n naught. If u is having n of n minus n naught. Clear? So that is how we will write all the formulas. So this will be using it while solving the formula. जैसे हम formula solve करेंगे तो हम सारे के सारे questions को use करते जाएंगे. ठीक है? Now let us solve the questions based on this. Compute y of n, write down, compute y of n if x of n, compute y of n if x of n given is just un and h of n given is alpha n un, that is alpha to the power n un for alpha is having a value between 0 to 1. 0 to 1 is the value of alpha. So this we need to remember because this can make a change for solving it. Okay? So for solving the question, we'll write the formula first. Summation k minus infinity to plus infinity x of k h of n minus k. Now what is our x of k? We'll write it in the formula minus infinity to infinity. This is our u of k. H of n minus k. H of n is alpha to the power n u of n, then alpha to the power n minus k u of n minus k. Now taking the multiplication of these two, what would be my range? Taking the multiplication of these two, u of k and u of n minus k. What would be my range? That is an important part to decide the range. Deciding range will solve the most of the part of the answer. Okay? So u of k, if I plot u of k, अगर मैं u of k plot करती हूँ, then my u of k will be plotted as this is -1, 0, 1, 2, 3, 4. U of k will be plotted like this. That is for positive side. Okay? So this is going to be my u of k. Now if I have to plot u of n minus k, u of n minus k matlab this is already minus of k. Minus of k, that means negative side. Negative k side. Here the negative k plus n. Now that depends on the value of n, whether n is a lesser value, that is n is less than 0 or n is greater than 0. Now if I take n less than 0, if I take n less than 0, then here is my n 0. This is -1. So n will lie somewhere here. मतलब यहीं कहीं पर lie करेगा negative side में. And my all my values will start in this direction and it will move in the negative k side. Correct? But in this two case, if I am taking u of k and u of n minus k, if n is less than 0, I won't get any common, right? And nothing in common. So in that case, I will not be getting an output. So I have to take the value of n somewhere here. Let us take it as 2 or let us take it as 3, anything which is greater than 0. So if I take this value, it will be like this. It will move in the negative side, negative k side. Clear? So this is going to be my u of n minus k, where n is greater than 0. Okay? So if I have to take the things in common, that is the multiplication of uk and u of n minus k, what would be the range? What would be the range? Yes, tell me now. इसमें range क्या आ जाएगा? Summation का range. K range will be from 0 to 0 से start होगा, because before 0 here it is completely 0. ठीक है? And after 0 we have the values of uk की value है, and we have the value of un minus k till the value of कहाँ तक है value? Only till n. So this will be the range will be only in between k 0 to n. ठीक है? The range will be in between only 0 to n. Now this is alpha to the power n. Since only k is a variable, we can take out alpha to the power n. Now this can be written as alpha to the power n by alpha to the power k. So we can even write it in that form also कि हम उसको दोनों अलग-अलग form में भी लिख सकते. Then we can find out the answer. Give me the answer now. जल्दी से बताओ क्या होगा. Yes? Solve it and give me the answer. Solve it, students, and give me the answer. I am waiting for the answer, everyone. It will be alpha to the power n minus k. यहाँ तक clear है? Everyone, it is clear till here, right? यहाँ तक clear है, everyone? Anyone who is still not clear? यहाँ तक जिसको clear नहीं है, just ask me. If it is not clear, I'll explain it again. Range is clear to everyone? Range is clear, right? Range should be clear because it is very simple to plot it when it is in terms of discrete. Discrete में है तो it is very easy to plot. ठीक है?
Ma'am,
हाँ?
ma'am, please explain once again how the range came.
Range? हाँ.
Please
Range?
explain it once again.
See, this is UK. Just be interactive, okay? If you will not be interactive, I won't be able to understand कि आपको समझ में आ रहा है कि नहीं आ रहा है. This is UK, right? U of k is clear because it's simple as like u of n. ठीक है, तो u of k will have the value starting from 0 and it will proceed till positive value of k, all the positive side of k. Now we have to plot u of n minus k. Now this particular formula is this one. ये formula में अगर हम लगाएंगे x of k will be u of k and then we have h of n as alpha n and u of n, alpha to the power n minus k because it is h of n minus k. So alpha to the power n minus k, u of n minus k. Now we have to plot n minus k. N minus k, that means we have to plot u of minus k plus n. Clear? Now here the variable is k. It is not n. That is the only thing that you have to remember. Variable is not k, it is not n, it is k. So minus k मतलब पहले ही clear है कि it will be in negative side, negative k side, that is negative values of k. And plus n. Now plus n मतलब n can be any value, whether it can be a positive value or a negative value. So that is what I plotted. If it is, suppose I am taking 0, minus 1, minus 2. Now let me take n as a negative value, that is a minus 2. So it will start from here and since it is minus k, तो minus k मतलब वो पूरा negative side में चलता जाएगा. It will go in this direction. पूरा इसी direction में रहेगा. Now if I take the common, that is the multiplication of u of k and u of minus k plus n मतलब n minus k, I won't be able to get anything in common because this is only for positive values of k, that is from 0 to positive values of k, and this one is for all the negative values. It is not even starting at 0 and minus 1 also. 0 पे है ही नहीं value, only for the negative values. तो इन दोनों में मुझे कुछ भी common नहीं मिल रहा है. So in that case, I have to take any value of n which is greater than 0. So if I take any value of n which is greater than 0, so let us take, as I have taken here 2 and I can even take it as 3. That is just as an assumption that I am taking. So if it is 3, if n is greater than 0, any value. So if it is 3, to 3, 2, 1, 0, minus 1. मतलब it will proceed again in the negative value of k. ठीक है? तो ये basically कहाँ तक जाएगा? n तक जाएगा. n की जो भी वैल्यू रहेगी, here I have taken n equals to 3. ठीक है? तो यहाँ पर मैंने n equals to 3 लिया, तो ये 3 से स्टार्ट होके minus k तक जा रहा है. And if I will multiply these two, तो मेरा common value कहाँ से आ रहा है? Here it is starting from 0 and going in positive k side. Here it is minus k to n, minus k to n हो रहा है. ठीक है? So what is becoming common? That is from 0 to n are the values which are common in these two. 0 to n are the values which are common in these two. Is this clear now? Is this clear now?
Yes, ma'am.
Clear now? तो ये आपका range decide कर रहा है, that is 0 to n. Alpha to the power. Now this is 1 in between this range. This is also 1 in between this range. Now since we are multiplying these two terms, this is becoming alpha to the power n minus k. Now by solving the summation, we have to find out the result out of it. ठीक है? Y of n is the value 0 to n के बीच में हमें चाहिए. ठीक है? Now in this one we have to solve it. n minus k है, n minus k है, तो इसको हम लोग चेंज कर सकते हैं. We can even take this n minus k as any other term. Let us take n minus k as m. ठीक है? m ले लेंगे तो ये समेशन क्या हो जाएगा? n minus k को हमने m ले लिया. Now when k is 0, the variable is changing to m, right? Now when k is 0, तो ये 0 है, तो m will start from n. When this is 0, m will start from n. Now when k value is n, it will be m will be 0. ठीक है? n minus m हो जाएगा, and this becomes alpha to the power m. We may even write it as summation m 0 to n. Alpha to the power m. Now this we can easily write the answer. इसका आंसर क्या होता है? We should know these answers because these answers are very important. What is our y of n now? Y of n क्या होगा? जल्दी से बताओ. alpha to the power m or anything, it will be summation. This is m 0 to n है ये, this becomes 1. Remember this one, this is an important part, 1 minus alpha to the power n plus 1. मतलब ये जो आपका result है, here you will be writing alpha to the power m, and this will be 1 minus alpha n plus y, 1 minus alpha. Now this is going to be the answer. ठीक है, ये फाइनल रिजल्ट है. दिस इज जस्ट बाय सॉल्विंग द ज्योमेट्रिक सीरीज, जो आपका जीपी सीरीज रहती है, ज्योमेट्रिक प्रोग्रेशन की सीरीज रहती है, उसको आप सॉल्व करोगे एंड यू विल बी गेटिंग दिस एज एन आंसर. 1 माइनस अल्फा टू द पावर n प्लस 1 बाय 1 माइनस अल्फा. ठीक है, ये कुछ कुछ सीरीज है, आपको हमेशा याद रखना पड़ेगा बिकॉज़ दिस विल ऑलवेज कम इन द क्वेश्चंस, क्योंकि ये क्वेश्चंस में रेगुलरली आते जाएंगे. इज दिस पार्ट क्लियर नाउ एवरीवन? Is this part clear? Now this was the answer only when we had taken n greater than 0. That was the case that we have already taken, that this is the answer, that when we had taken for n which is greater than 0. So what is required to be added here? What is required to be added here? Jaldi se batao, what is required to be added here? This is the answer. Y of n equals to 1 minus alpha n plus 1 by 1 minus alpha into u of n. U of n is required to be added. That is only because of the reason that we had taken this answer for n greater than 0. N greater than 0 was our condition. So this is the case that when we take the condition, then we need to add that thing, because उसके बिना अगर हम करेंगे तो it will be it will be not sufficient, वो complete नहीं रहेगा आंसर. ठीक है, so just to make the answer complete you have to add it. ठीक है, now let us solve the another question. If I take the another one is, it is an simple one but that is again an important one. अगर आपको ये clear हो जाएगा then it will be very much easy for you. It was similar as what we did. We have to compute y of n. Then x of n given is 0, 1, 2, 3. And h of n given is 0, 1, 2, 3. All these values are 1. Now for this x of n and for this h of n, we have to find y of n. ठीक है? How can we do that? कैसे solve करेंगे question को? This question is very simple, but you will have to just understand how to solve it. This is the question that we did. यही question था जो हमने solve किया था in case of continuous time LTI system. ठीक है? Now the same question is here in case of discrete time LTI system. Here it is from 0 to 3. There it was there from 0 to 3 only. And here this one h of n is in between 0 to 2. Now how will you solve this question? Tell me fast everyone. How will you solve this question? Yes? Nobody is hearing today. No one is attentive in the class. How will you solve this question? Yes, students? X of n can be written in terms of del n. X of n can be written in terms of del n. इसको del n के terms में लिखेंगे तो how will we write in terms of del of n? It will be del of n plus del of n minus 1 plus del of n minus 2 plus del of n minus 3. This is how we'll write our x of n. Similarly, we can write our h of n. H of n can be written as del n plus del n minus 1 plus del n minus 2. ठीक है, so that is how we'll write our x of n and h of n. Now what is the purpose that why are we writing in terms of del n when we can easily write in terms of un also. हम इसको un के terms में भी लिख सकते हैं, but we know that we have the property of xn convolution del n and we can make use of that property. Now let us see if we have to find y of n. What is it? It's x of n convolution hn, right? It's x of n convolution hn. That is what is our y of n. If we directly not go into the formula, the basic thing that we know is it is x of n convolution hn. Now we'll just replace the hn by these values. We'll just replace the h of n by this values. It will be x of n convolution del n plus del n minus 1 plus del n minus 2. Now we'll take the individual convolution here. This becomes x of n convolution del n plus x of n convolution del n minus 1 plus x of n convolution del n minus 2. ठीक है, so I've taken x of n convolution with this, x of n convolution with del n minus 1, x of n convolution with del n minus 2. So that is how we'll take the entire convolution. Now after this we'll just apply the property. उसके बाद हम सिर्फ इसकी property apply करेंगे and we'll see what we'll get as a result. Now tell me what is x of n convolution del n. What is x of n convolution del n? Yes?
X of
it
n.
is only x of n. Correct. Plus, what is it? X of n convolution del of n minus 1. ये क्या हो जाएगा? ये क्या होगा?
X of n minus 1.
It is x of n minus 1. And this one, the last one, x of n convolution del n minus 2, it will be x of
n minus 2.
ठीक है? So this was our y of n. Now we already know what is our x of n. X of n क्या था हमारा? What was our x of n? X of n was del of n plus del of n minus 1 plus del of n minus 2 plus del of n minus 3. So this was our complete xn. Now we'll apply this in this formula. हम इस formula में इसको completely apply करेंगे. What it is going to be? Y of n equals to. Now this is my complete x of n. So I'll write it as it is. Del of n plus del of n minus 1 plus del of n minus 2 plus del of n minus 3. This is only for x of n. Plus, I have to write for x of n minus 1. If I apply x of n minus 1 in this particular thing, it will be del of n minus 1 plus del of, this becomes n minus 2 plus del of n minus 3 plus del of n minus 4. So in the entire value of x of n, I am applying n minus 1. So this is going to be my second term, this one, x of n minus 1 plus the third term, x of n minus 2. So for the entire x of n, I'll have to apply n minus 2. This becomes del of n minus 2 plus del of n minus 3 plus del of n minus 4 plus del of n minus 5. Now I need to add the things because few of the terms are in repetition. कुछ repeat हो रहा है तो वो मुझे add करना है. Now let's see what is the final answer. See, in this case, I didn't have to solve it. मुझे कुछ भी solve नहीं करना पड़ा. I just needed to think that how can we approach the question because we already know the property of x of n convolution del n or x of n convolution del n minus 1 or n minus n naught. So that is what is the thing that we used here. Okay? So this one del of n is taken once. Plus, let us see del of n minus 1. This one once and twice. 2 del of n minus 1. ठीक है? 2 del of n minus 1. Then del of n minus 2 is taken twice. 3 times del of n minus 2. Then n minus 3 is also taken twice. Plus 3 times del of n minus 3 plus n minus 4 is taken twice. 2 del of n minus 4 plus del of n minus 5. So this is going to be my answer. तो ये answer, is this part clear? यहाँ तक clear है? यहाँ तक clear है, right everyone? How have we solved this question? This was very simple that we did. अब यहाँ पर just by applying the formula कि आपका आंसर क्या आ रहा है, n की values के बाद we can easily write if n is 0. For n 0 पे the value is 1. ठीक है? And if n is 1, the answer is 2. If n is 3, the answer is 3. If n is 4, the answer is 3 again. ठीक है? सॉरी, ये 0 पे है, ये 1 पे है, ये 2 है, ये 3 है. 3 पे it is 3, 4 पे it is 2 and 5 पे it is 1 again. So this is going to be my y of n. Clear now? This one is clear. So ये मेरा y of n रहेगा. When n is 0, the value is 1. When n is 1, the value is 2 because it is 2 then n minus 1. ठीक है? It will exist only at n equals to 1. Rest will be 0. बाकी सब 0 हो जाएगा. So we don't have to worry for other values. जब n 0 रहेगा तो ये भी exist करेगा. Rest will be 0. ठीक है? So at n equals to 0, since its value is 1, it will be 1. So at n equals to 1, rest will be 0. Only this will exist. And the value here is 2. So I have written 2. At n equals to 2, the value is 3. So I have written 3. At n equals to 3, the value is 3. So I have written 3. At n equals to 4, the value is 2. So I have written 2. n equals to 5 पे, again it is 1. Now I guess this part is clear to everyone. Anyone who is still not clear with this, इसको कैसे solve करना है मैम? Clear now everyone? No one has any doubt? Okay. ठीक है. Now let us do another question. If you have to solve the question graphically, how will you do it? Graphically, मतलब graphical convolution in case of discrete, आपको individually plot करना रहेगा. Just like what we did in the case of continuous time. Continuous time में आप individually plot करोगे, n minus k जो रहेगा उसको आप individually shift करते रहोगे. For different values of n, मतलब अलग-अलग positions में रखोगे n को because it is n minus k and we know that the variable is k, it is not n. ठीक है? तो n की different positions में shift करेंगे and then we will plot. I'm not doing this because we have already done this the same type of question in continuous time, so it will be same in case of discrete time as well. ठीक है? So that is not required to do it in the case of discrete time. So that is the reason that I'll give you that question in assignment. We'll do it later. ठीक है. Now let us do another question. Let's see. If I'll explain you one important concept. This step response. Now what do you mean by step response, students? Step response का मतलब क्या होता है? Like impulse response. What is an impulse response? Impulse response का मतलब क्या होता है? It is the response when the input is del t. ठीक है? In continuous time, it is the response when the input is del t. Similarly, the step response, when we talk about the step response, अगर हम अभी continuous time की बात करते हैं तो if we talk about a step response, ठीक है, step response is represented by st, ठीक है, and it is the response of continuous time LTI system when the input is ut. ST is the response, step response is the response of a continuous time LTI system when the input is ut. ठीक है, तो जब input ut रहता है तो आपको step response मिलता है. So as we have already seen in the case that for a continuous time LTI system, if we are giving an input u of t, the output will be getting is s of t, that is the step response. And similarly, if we give the input xt, what we get as an output is yt. Now what would be my yt? Yt क्या होगा? Here yt is nothing but xt convolution st. xt convolution st. Instead of यहाँ पर ht हुआ करता था, if we have taken del t as an input, we get the output as ht. Now here I am giving ut as an input. My output is s of t. S of t is the step response. ठीक है, तो s of t step response हो जाता है. तो here the same thing will happen again. Instead of ht, I am writing it s of t. S of t is the step response that we need to understand. Now in the case of continuous time also, y of n is x of n. Discrete time also it is s of n. Y of n convolution s of n in case of discrete time. ठीक है, तो आपका सेम रहता है. The concept is always same. What you need to understand कि यहाँ पर आपका continuous time है और ये आपका discrete time है. ठीक है, so here it will be in terms of s of n. Now what is an important thing to understand is if I write the formula as we have already seen this one, अगर मैं yt कैलकुलेट करती हूँ कंटिन्यूस टाइम में, इट इज इंटीग्रेशन माइनस इंफिनिटी टू इंफिनिटी x ऑफ टाउ. ये क्या हो जाएगा? इफ इट इज इन टर्म्स ऑफ स्टेप रिस्पांस, तो ये क्या हो जाएगा? इफ आई हैव ऑलरेडी रिटन, लेट मी राइट दिस वन, x ऑफ t convolution s of t. ठीक है, so in this case it will be minus infinity to infinity x of tau s of t minus tau. ठीक है, s of tau is s of t minus tau b tau. क्लियर? तो ये आपका चेंज हो जाएगा. दिस इज गोइंग टू बी s of t minus tau. क्लियर? तो दिस इज s of tau because as we have seen यहाँ पर हम लोग xt लेते थे. Here this will become st हो जाएगा, and this becomes s of t minus tau. And we know that since because it is a continuous time LTI system, तो अगर हम u of t minus tau input दे रहे हैं, if I am giving the input as u of t minus tau, my output will be s of t minus tau because it is a continuous time LTI system. ठीक है, it is a continuous time LTI system. तो ये बिल्कुल ऐसी का ऐसी आउटपुट आ जाएगा. Are you getting my point? That is only because it's a continuous time LTI system. So whatever is the shift in the input, the same shift will appear at the output also. The same shift will appear at the output. So this is how we'll write the formula. Now u of t minus tau will exist for what duration? ये कौन सा duration के लिए exist करेगा? This will exist only for minus infinity to t. ये minus infinity to t पे exist करेगा. But for this I'll get certain value of s and this is not fixed कि ये कौन से duration पे exist करेगा. That will exist for any duration. वो किसी भी duration के लिए exist कर सकता है. But definitely it will have the value as t minus tau. Clear? So that is how we can write. Similarly, in the case of this also, we can write it as summation k minus infinity to infinity x of k s of this becomes n minus k. For discrete time we can write it in this form. For continuous time we can write it in that form. Okay? And the numericals based on these two concepts will solve in the next class because the numericals will take a little time to understand and this will not be possible to do it now. ठीक है? तो ये concept है, बस आपको ये ध्यान में रखना है कि step response is nothing but the response of a system when the input is a unit step function. ठीक है? When the input is a unit step function, you will get the response as a step response. That is what is the important thing to understand and to remember. In case of continuous time also or in case of discrete time, दोनों के case में it will be same. Clear? So that is how we'll have a step response.